So we're going to start with a slideshow. Then we're going to bounce into some old-fashioned notes like you used to have in Algebra 2. And then we're going to go back to the slideshow for some application problems. There's a couple differences in the way the book does this and the way I tend to look at it, so I will combine the two. First of all, though, let's talk about what a conic section is. We're going to start Chapter 10, which is conic sections. And so this first 4-slide piece is just what are the conics and how do we figure out what they are or what they look like. So the names of the conics. If you have a conic, 2 cones stacked end to end like this, and you cross them with a plane, you section it. When you dissect something, you can take a cross section or a section and look at it. And so if you slice the cone perpendicular to the cone, you get a circle. If you have an angle on the cone, then you get an oval or an ellipse. If you slice the cone and come out the bottom, then you have a parabola formed between the cone and the plane, where the cone and the plane intersect. And if you slice where you come out both the bottom and the top of the cone, you get what's called a hyperbola, which is like 2 parabolas that are facing opposite directions. A lot of conics have applications in physics with lenses and mirrors, and so we'll talk a little bit and we'll show a couple of the application problems at the end. Now I want to talk a bit about some of the differences in the equation and some of the things that are mentioned in the book that are not exactly like what the notes you're going to see. The first thing I want to talk about, and this is section 2 where actually your homework is going to be based on. We're going to talk about parabolas with vertexes at the origin, parabolas with vertexes at HK. We're also going to talk about parabolas that open sideways. So we kind of know the up and down parabolas because those are functions. But we're also going to deal with parabolas that open left and right. And then we'll come back to the PowerPoint when we get to applied problems. We have in a parabola, there's a focus and a directrix, and we'll talk about that more. I wanted to get to see if they have the basic formula here somewhere. The y squared is equal to 4ax. And the main difference you're going to see in our notes is instead of having the 4a, this 4a is a number. That 4a is going to be some number. And you're going to figure out what a is. In my notes that I have for you, it's written like this. It would be x is equal to 1 over 4c y squared. And it's the same thing. They've just replaced the a with a c. We can make it an a if we want to, but I'm going to leave it a c in the notes because they're already printed that way. But it's just taking that if I had it as a 4a here, you can see I just divided by 4a on both sides. And so I can get the 1 over 4a y squared and only have the x left on this side. And so that's the kind of the difference in the way the formula is written. It's still the basically it's the same formula, but different notation, different way of writing the same thing. Okay, so we're going to take and we're going to kind of minimize this PowerPoint and go to the notes. You should have note pages with you that were given to you to fill out, and so we'll look at those as we go on. That's the one I want right there. So let's see if we can make this bigger so it's easier to write on for us. Try that. Is that big enough? Oh, why not make it bigger? Okay. And I'd like to get rid of a lot of this stuff. Okay. So parabolas, day 1. This is really originally something I would do over several days. But we're going to talk about the what a parabola is. The standard form for the equation is y minus k is equal to plus or minus the 1 over 4a if you were looking at the book, but we're going to leave it 1 over 4c times x minus h squared. So this standard form doesn't really differentiate between whether it starts at the origin or starts at a certain vertex. And the vertex is going to be hk. Again, this is going to feel like, remember when we did parabolas, it felt like we changed the sign coming out of the parentheses. This is going to feel like you changed the sign for both of these things because the standard form has the x minus. And so what you've got, you know, when you look at this, you know, that when I pull out the k, it doesn't, the sign doesn't come with it. That's part of the equation. And same thing in here. To get the plus, you have to change them to negative when you pull out your h and k from these formulas. These open up or down. I open vertically because the x is the squared term. So that's what you notice with the vertical up and down. It's an x squared. Okay? There is a line called the directrix behind the parabola or below it or above it if it opens down, and a fixed point that's inside the parabola, inside the cup of the parabola, called the focus. And that will be the focal point when we talk about mirrors and lenses. Okay, so we know that. There's also a term that's used that not in these notes, but is used for this line that goes from here to here, from these 2 points. These points are 2C, or could be considered 2A if we use the letter A instead of C, away from the focus. And the name of this line, which you can see why you probably don't talk about it much in high school, is the latus rectum. And that's referred to in your book, and if we have any online assignments, when they refer to the latus rectum, they refer to that line that's perpendicular, parallel to the directrix, and goes through the focus. Okay? So now let's work on graphing some of these parabolas and go from there. So we're going to start with this one. 1/8 x squared. Y is equal to 1/8 x squared. And you're going to notice, first of all, there's no h and k. So what does that mean for practical purposes? That means that our vertex is at 0, 0. Okay. 1/8 is positive, so just like we always talked about, if the number in front is positive, it opens up. Okay. So our parabola is going to open up. Now C, 8 is equal to 4C. So C must be equal to 2. Okay. So let's talk about on our graph. Let's locate some of these things on our graph. We've got 0, 0. If C is equal to 2, that means our focus, and it opens up, our focus is 2 above the vertex. So our focus is going to be at 0, 2. So we can go ahead and write our focus point. Okay. And our directrix is going to be 2 behind that vertex. So our directrix is going to come across. It's the line that goes behind the parabola. So this is the directrix. So the equation of the directrix is the equation of a line, a horizontal line, y equals -2. Now, we know that these points that we're going to locate along the latus rectum are 2C or 2A away from the focus. So they're going to be, since C is 2, 2 times that is 4. So they're going to be located 1, 2, 3, 4 points, 4 spaces to the right, and 4 spaces to the left. 1, 2, 3, 4 of the focus. And so those points are at 4, 2, and we can put that on this little graph, or little table, 4, 2, and at negative 4, 2. That's where those 2 points are found along the edge of the parabola. And we take those points then, and we just then draw in the parabola going through those points. Okay? And that's how you're going to do this. So let's look at our next problem. Okay. This one does have a different vertex. And remember, it feels like we changed the sign. So let's look at our vertex. Our vertex is going to be at negative 3, 2. Remember, to get a plus in there, it's minus a negative 3. And then that's just a 2 when we think of take the K and take the H. The H is in with the X. And the K is in with the Y. So with the Y. This, because of the negative right here, is going to open down. And again, you know that. You've done these before. So that opens down. Then we want our C. Well, 2C is equal to, 4C is equal to 4, so C is equal to 1. So let's put our vertex here, which is at negative 3, 2. 1, 2, 3, 2. There's our vertex. Going to the graph. Then since it opens down, our directrix is above, one space above that vertex. So here's our directrix coming along here. It's the opposite side from the way the parabola opens. And so that's going to be at y equals 3. So we can write that on there. And our focus is going to be inside the parabola, one space inside. So our focus is going to be at negative 3 and 1. Okay? Now, 2 spaces, 2 times C on either side of the, so our 2C is equal to 2, because C is equal to 1. So 2 spaces on either side of this focus, right here and right here, are going to be points on the parabola. Okay? So at negative 1, 1, and at negative 5, 1, we have points that are on the parabola. And then we can sort of draw it in. Okay. So that's our second example. Our third example, our vertex will be at negative 4, negative 6. And it's going to open up because 1/12 is positive. C, if we think of 4C is equal to 12, C is equal to 3. Okay, so we're going to go here to negative 4, negative 6. 1, 2, 3, 4, 1, 2, 3, 5, 6, and there's our vertex. Okay, it opens up, so our directrix is underneath it, 1, 2, 3 spaces away. So we can draw in our directrix. Okay, which is at y equals 9, negative 9, excuse me. Our focus is going to be 3 spaces to the other side of the vertex, so 1, 2, 3. So our focus is going to be at negative 4, negative 3. Okay, and so if C is 2, C is 3, 2 times 3 is 6. So our other points on the parabola are going to be located 6 spaces to the left and right of the focus. So 1, 2, 3, 4, 5, 6. There's a point there. 1, 2, 3, 4, 5, 6. There's a point there. And so those will be located at negative 10, negative 3, and at 2, negative 3. And then we can draw in the parabola. Okay. So far so good, I hope. Alright, so let's move down. Now we're going to talk about the left and right parabola. What you notice on the left and right parabola is that y is squared. So for the left and right parabola, y is squared. That's really the only difference, but you have to be careful because we intend to write it reversed on the sides. So, you're going to pull your x from the left side and the y from the right side. But h is still with the x and k is still with the y for your vertex. It's still plus or minus 1 over 4c. But now we're going to go up and down instead of left and right to find those extra points from the focus, to find those extra points on the parabola. But they're still 2 times c distance away from the focus. The directrix is still, it's going to be to the left or right of the vertex. The focus will still be inside the cup of the parabola. If it's opening right, that's when you're going to have your positive number, 4c, 1 over 4c, and left, it's going to be your negative 1 over 4c. Okay? So, let's go and work some problems, 2 or 3 problems with that. And then we're going to start with an equation and try to figure out how to get the graph by completing the square. Okay, so let's go on down. This is the same basic problem as we had to start our other with, except since our y is squared, it opens right. Okay, so this one opens right. The vertex is at the origin because there's no h or k added on there. C, 4c is equal to 8, so c is equal to 2. So we've got, starts at 0, 0. So we've got points 2 to the left and 2 to the right. Now which one's the focus, which one's for the directrix? Since it's opening right, this is your focus. And so your directrix will come here through this point. And since it's a vertical line for a left-right facing parabola, the directrix is an x equals line. So it's going to be x equals negative 2. Our focus is found at 2, 0. And then we're going to go 2 times c, 2 times 2, are 4 spaces away from the focus, up and down. 1, 2, 3, 4. 1, 2, 3, 4 for our 2 points, other 2 points on the parabola. And so those will be at 2, 4, and at 2, negative 4. And then we can draw in our right facing parabola. Okay. Okay, moving on down for another example. This one, it's a negative, so right away we know, and we see that the y is squared. So this one is going to open left. Okay. Our vertex is going to be at 2, negative 3. The 2 is with the x, so that's the x value of the vertex. Remember, feels like you change your signs. If 4c equals 4, c is equal to 1. So we have a vertex at 2, negative 3, right there. And we have a point at 1, and at 1 behind it. It opens left, so this is going to be our directrix, which is behind it. So that's going to be at x equals negative 1. Except I put my point on here wrong, so let me go back and erase. That's one thing nice about this. I hope you're working in pencil. Okay, so I went negative 2. So I've got to go to negative 3, which is down here. And then have a point and a point. Okay, so since it opens left, we've got our directrix here, which is at x equals 3. Okay. And then our focus, we've already got it marked, is at 1, negative 3. Okay. 2 points that are on the parabola, the other 2 points are going to be 2 times a, or 2 spaces away from the focus, up and down. So that will be at 1, negative 1, and at 1, negative 5. Okay. And then we draw in our parabola. All right. One more example of this. Okay. This one opens right because it's a positive 1/12. Okay, so it opens right. Our vertex is at negative 1, 2. Okay, so we're going to put a point at negative 1, 2. Then our C, if 4C is equal to 12, C is going to be 3. And it opens right, but we're going to go 1, 2, 3 to the left, 1, 2, 3 to the right. It opens right, so this point on the left is going to be the point where our directrix goes through. So the directrix is at x equals negative 4. And our vertex is at 2, 2. All right, from the vertex, we go 2 times 3 points. So we're going to count 6 points up and down from the focus, not the vertex. 1, 2, 3, 4, 5, 6. We have a point above it. 1, 2, 3, 4, 5, 6, a point below it. And those points are at 2, 8. And at 2, negative 4. And then we can use our vertex and those points to draw our right-facing parabola. Okay. Now I'm not going to draw the next one, but if you got on a roll and we're going to look at this one, you might look at it and say, okay, whoops, where am I here? Something went wrong. Here we go. Okay, I didn't put the fourth one on there, I guess. I had an x squared on there that I was thinking about throwing in there to see if you noticed. But anyway, so notice which term is squared, because if it's x squared, it's up and down. If the y is squared, it's left or right. Now this is the general form of any conic. ax squared plus by squared plus cx plus dy plus e, which is a constant, equals 0. Now for a parabola, there's not one of those squared terms is missing. There's only one squared term in a parabola. So you'll have potentially you'll have the C, D, and E, but you will only have either an A or a B. You're only going to have one squared term. And those are the two standard forms that we've talked about already. Now we're going to convert these to standard form by completing the square. And then we're going to graph it. And so you know how to complete the square. But let's just talk about doing that. And hopefully we have plenty of room. We do. When you complete the square, what you want to do first, and I'm going to start here where I can kind of see both things. I'm going to start under the word directrix so you'll know where I'm about to start writing. I'm going to leave the x's together, what I want to complete the square on. So I'm going to have x squared plus the 4x, and then I'll put my blank, you know how I like to do that, equals, and I'm going to bring everything else over to the other side of the equal sign, so it'll be negative 8y and plus 4 equal, okay, move it like that. Now you're going to complete the square. Remember, this is b over 2, so that's 2 squared, which goes in there. And I'm going to add 4 here to the other side, because if I add 4 to the left side, I have to add 4 to the right side. Okay. So then when I write this as a factored polynomial, I get x plus 2 squared is equal to negative 8y plus 8. I'm going to factor out a negative 8 from the right side, and that'll give me y minus 1. Okay. Now, you can leave it here if you want to, and know that this is your 4C or 4A, depending on which book you're looking at. Or if you want to put it in the standard form like we've done it, you would divide by that, and you would end up with negative 1/8 x plus 2 squared, and then you would have y minus 1. Okay, and so that would be the standard form that goes up in this blank right here, right there. I'm not going to rewrite it. But that's what I would put in that standard, in that blank. Now, it opens up or down. It's an x squared. Opens up or down. Since it's negative, it's going to open down. Okay, so from here then, we can graph it pretty easily. Our vertex is negative 2, 1. Okay. 4C is equal to 8, so C is equal to 2. And from here is just what we've done before. We have a negative 2, 1. Okay. Opens down, so we've got above and below it 2 spaces. That's our C. Since it opens down, this one's our directrix here. And so that's y equals, horizontal, sorry, y equals 3. And our focus will be at -2, -1. And then 2 times c is 4, so 4 spaces to the right and left of the focus. 1, 2, 3, 4. And 1, 2, 3, 4. We've got our points on the parabola, and that allows us to draw in the graph. Okay. Okay, another example. All right, here we've got y squared. So we're going to write the y terms together. Y squared minus 6y plus blank equals 8x plus 7 plus blank. So this will be a -3 squared, -6 divided by 2, and that means I'm going to add a +9. So I'll have 8x plus 16, and that's going to equal y minus 3 squared. Factor out an 8 here, so that's going to leave me with x plus 2. So when I divide by 8, my standard form, and I'll write it in the blank this time, will be x plus 2 equals 1/8 times y minus 3 squared. Okay, so the y is squared, so it's a left to right facing parabola. The 1/8 is positive, so it's going to open to the right. The vertex will be at -2, 3. Okay, 4c is equal to 8, so c will be equal to 2. So we'll go here on our graph, and we'll put our vertex on there at -2, 3. And then we're going to count 2 spaces to the right and 2 spaces to the left. Since it opens right, our directrix is here behind that, to the left of the vertex. And so that is an x equal line. X equals -4 is our directrix. And our focus is sitting at 0, 3. And then 2 spaces, 2 times 2, 2 times c spaces, which is 4, away from the focus. 1, 2, 3, 4 above it. And 1, 2, 3 spaces below it are the other 2 points on our parabola that let us draw in the graph. Isn't this fun? Okay. So, I think you know how to do this. I think you're probably pretty good at completing the square. I'm going to work these other examples out. If you want to fast forward and go to the application problems, feel free to fast forward at any point. I'm going to go ahead and work through these two. Okay, so again we have y squared. It's going to open left or right. So let's start with completing our square. We have y squared. So we have y squared is equal to, let me go ahead and get that off because that annoys me. Okay. Alright, so y squared is equal to, y squared minus 8y plus blank will be equal to -12x plus 20. This will be a negative 4 squared. And so we'll add 16 over here. So we have negative 12x plus 36. And here we'll have y minus 4 squared. We want to factor out a negative 12, which is going to leave us with x minus 3 and y minus 4 squared. So when I divide by negative 12, I'll end up, and I'll write this up in the standard form space, x minus 3 equals negative 1/12 y minus 4 squared. Okay, so since it's negative and the y is squared, it's going to open left. Okay, our vertex, will it be at 3, 4? C, 4c is equal to 12, so C will be 3. So we can graph that pretty quickly. We're going to go to 3, 4, 1, 2, 3, 1, 2, 3, 4. It's going to open to the left. Okay, so we're going to go 3 spaces behind it and 3 spaces in front of that vertex. Since it opens left, our directrix is this goes through the point to the right. So our directrix is going to be at x equals 6. Okay, and our focus is going to be at 0 and 4. Okay, so 2 times 3 is 6, so 6 spaces up and down from our focus. 1, 2, 3, 4, 5, 6 up, and 6, 1, 2, 3, 4, 5, 6 down. It gives us our extra points that we need to graph our parabola. Okay. And the last example for this homework, and then we'll go through back to the PowerPoint and look at some of the application problems. This is x squared. So in this case, it's going to be up or down. So we're going to have x squared minus 6x plus blank equals positive 4y minus 5. And so that'll be negative 3 squared. And we'll add 9. Okay, so this will be 4y plus 4. Factor out our 4 and we'll have y plus 1. Over on the left side, we're going to have x minus 3 squared. And so when we write it up in our standard form, we'll have y plus 1 is equal to 1/4 x minus 3 squared. Okay, so our vertex, it opens up, it's a positive 1/4. Vertex is at 3, negative 1. Be careful with where your x's and y's are when you pick out your vertex. C is 1. So at 3, negative 1, excuse me, you have your vertex, and 1 space below it, since it opens up, whoops, I started to write in the wrong spot. 1 space below it is our directrix. Which is y equals negative 2. Okay, 1 space above it is our focus, which is at 3, 0. Okay. 2 spaces away from the focus on each side. We have our points on the parabola, and so we can graph. Okay. So that gives you an idea about our first conic section, which is the parabola. And then we'll go from there with a couple more. Let's go back and look at the PowerPoint real quickly. And go down here to the application problems. Okay. And we want a slideshow from current slide. Okay. So we're looking at applied problems involving parabolas. And again, not surprising, they have to do with mirrors and lenses. Okay, so we have the rays of light coming straight out, and we have a lens that's curved, okay, and it hits the sides and bounces so that it becomes straight, goes straight out. We also might have a telescope. So we have the light coming into this telescope, hitting a mirror, bouncing that back. If you notice, it's coming in straight here. It's going to hit this mirror and bounce up to this another mirror, and you're looking at a lens, and each time this is magnifying, you notice the sizes, and it's going, and you're seeing through here the image that's coming in through here. And all that has to do with the focal points, and this is going to be the focal point that you're going to be able to see the reflection from these different mirrors or lenses. Okay, so here's a satellite dish. It's shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. If the dish is 8 feet across at its opening and 3 feet deep at its center, at what position should the receiver be placed? That is, where's the receiver is going to be at the focus. Okay, so you've got this satellite coming in, and it's 8 feet across and 3 feet deep at the center. And you want to know things are going to come in and bounce so that they hit that receiver. Okay? So if it's 8 feet across, the center, you're going to locate that vertical axis at the center. Will be at 0A is where you want to locate the receiver. Okay, and the outside points are at 4, 3, and at negative 4, 3 because it was 3 feet deep. Okay, so they're using this form of the parabola. X squared is equal to 4AY. Again, you could say 1 over 4C equals, or Y equals 1 over 4C equals X squared. It would be the same thing. So just to translate it, I guess, into what the language we used, but feel free to go back. If I was going to do this, or for what we used, we had Y is equal to 1 over 4C times X squared. Now they located the vertex at the origin, so we don't have to worry about they deliberately, when they drew their scale, located at the origin. Okay? So X is equal to 4 and Y is equal to 3 because we located the X in the middle. Solve for A, and so you can just put, in this case, solve for C. But A is equal to 4/3, so the receiver should be 1 1/3 feet, or 1 foot 4 inches from the base of the dish, along that axis of symmetry. Because you have the axis of symmetry with a parabola that goes right through the vertical through the vertex. Okay? So it's a little bit confusing, the fact that I used a different formula, but it's hopefully not not too confusing. You can see that it's the same thing. Okay? And I think that's the only applied problem they have. I don't really have an applied problem on your homework, but I will throw in one on the next homework or two that we have. Well, in fact, go into your book when you get home and add an applied problem. Pick one. Pick one. From the back of this section 10.2 and put it on your homework. Put it on the back of your homework that was given to you today when you turn it in.